Hello and welcome to my video on ENSO, the El Niño Southern Oscillation. Imagine the entire Pacific Ocean as a giant seesaw. On one side, you have Indonesia and Australia, where the waters are typically warm and the weather is wet. On the other side, you have the coasts of South America, where the water is colder and the weather tends to be dry. But sometimes, the seesaw tips over, causing some major weather changes across the globe. That's what we call the El Niño Southern Oscillation, or ENSO for short. ENSO is a natural climate phenomenon that happens in the tropical Pacific Ocean. It involves changes in sea surface temperatures and the atmospheric pressure in the Pacific, which affect not only the Pacific region, but the entire planet's weather patterns. There are three main states of ENSO: normal conditions, El Niño, the warm phase, and La Niña, the cool phase. Let's break these down. Under normal conditions, the trade winds, which are just winds blowing from east to west, push warm surface water from the eastern Pacific towards the western Pacific, near Indonesia. This pushes the sea surface height, or SSH, up by around half a meter in Indonesia compared to Ecuador, for instance. Meanwhile, as the warm surface water moves west, the cold, nutrient-rich water from below is pulled up along the coasts of South America. This process is called upwelling, and it brings cold water full of nutrients to the surface. This is great news for the fishing industries of countries like Peru and Ecuador, where upwelling supports tons of fish and plankton, which makes the ocean a huge source of food and income. Now, when El Niño happens, the trade winds weaken or even reverse. This causes the warm water that was pushed upwards towards Indonesia to spread across the central and eastern Pacific instead. When this happens, the sea surface warms up, and the SSH near the coasts of South America can drop, while it rises near the central Pacific. These changes mess with weather patterns and cause unusual weather. For example, parts of South America might experience heavier rain and flooding, while places like Indonesia and Australia could face droughts and wildfires. Not to mention, the warmer water causes thunderstorms to develop over the Pacific, making things even more extreme. Upwelling also gets weaker during El Niño, which means less cold, nutrient-rich water rises to the surface. This can affect the fish population, hurting fishing industries and even the global food chain. On the other side of the seesaw, we have La Niña, the cooler phase of ENSO. During La Niña, the trade winds become even stronger, pushing more warm water than usual towards Indonesia and Australia, while the eastern Pacific gets even colder than usual. Now in this case, stronger trade winds mean stronger upwelling off the coast of South America, bringing even more cold, nutrient-rich water to the surface. This is great for fishery industries, but it also brings heavy rain to Southeast Asia and can cause flooding in countries like Indonesia and Australia. Now once again, La Niña also causes weather changes all around the world, such as colder winters in the US and Canada and drier conditions in southern South America. It can also lead to more intense hurricanes in the Atlantic Ocean. At the heart of ENSO, the key factor is the interaction between ocean currents and atmospheric pressure. The trade winds, which blow from east to west, push warm water along the Pacific Ocean towards Indonesia. This creates a pressure gradient, meaning the atmospheric pressure is lower in the west because the warm water is rising there. Meanwhile, the eastern Pacific has cooler water and higher atmospheric pressure. The stronger the pressure gradient, the stronger the trade winds pushing the warm water westward. But when the trade winds weaken or even reverse, this balance shifts and the pressure gradient weakens. As a result, the warm water spreads across the central and eastern Pacific. When this happens, it triggers El Niño. The disruption of the pressure gradient leads to warmer waters in the east and a shift in weather patterns. On the other hand, when the pressure gradient becomes stronger again, the trade winds push even more warm water towards Indonesia, leading to La Niña conditions. Both of these shifts mess with the global weather, changing rainfall, storm patterns, and temperatures all over the world. Now a big question you might be having is, why does all of this matter? Well, ENSO has a huge impact on our weather and climate, which affects everything from agriculture to fishing to natural disasters like drought and flooding. It's especially important for people who live in areas like Australia, South America, and the United States, places that can be directly affected by El Niño and La Niña events. ENSO is a fascinating but powerful phenomenon that shows just how interconnected the Earth's oceans and atmosphere really are. So the next time you hear about El Niño or La Niña, you'll know that it's not just some random weather event. It's a global force with the power to shape the world's weather in some very dramatic ways.